Hey guys, welcome to Unit 0 review. So this is Miss Samaru.
And this is Miss Ewing.
So we're going to go over the test that we just took. This will be a guide for you when you're studying for the region. So we're going to go over piece by piece. The first one is just evaluating expression. So I'm giving this expression and I need to find the value. What is the value of this expression when x is 3 and y is -2? So all I'm going to do is just plug in wherever I see x, I'm going to replace it with 3. And remember, my negatives, I go in, no x. Wherever I see x, it will be, 3 squared.
Wait, Miss Samaru, so why do you have negative parentheses -2?
Because y is -2, as you can see right here. So it's minus y, so I keep the minus and I put the negative in parentheses. So if we work this out, remember PEMDAS, negative and negative, this will be addition, minus 3 squared is 9. So when you work this out, we're going to get from left to right, just this 7 plus 2 minus 9. This should be 7 plus 2 is 9, minus 9 is 0. So your first answer should be 0. Now for number 2, we have RP minus P cubed. And I want to find a value when P is -3 and R is -5. So R is -5. I like to keep my negatives in parentheses. So negative.
Miss Samaru, I think you made a mistake. It's P cubed on the end.
Oh,
not
P
squared.
cubed. Thank you, Miss Ewan. That's a cube, not square. And that was a mistake that we made on the test. See, I did it too. So let's do our -5 times -3. This is a positive 15 minus -3 cubed. Remember, this is -3 times -3 times -3. This works out to be a -27. So if you don't know what to do, keep change flip or use your calculator. You'll get 42. So moving right along. Let's see how this goes. Simplify an expression, Miss Yu, and I'll do 3 and 4. You want to do 5 and 6?
Sure.
All right, so first thing we do here is distribute. This becomes 4x squared minus 8x. Remember, x times x is x squared. And this is minus 5x. This will be minus 10x squared minus 20. Combining like terms. What are my like terms? I have the ones that have the same variable. I think I'm missing something, Miss Ewan. This should have been an x. And I know that this and this are my like terms. So when I combine these, I will get my negative x squared minus 28x.
Okay, so for number 4.
Let's start distributing. That's the first step. Whenever you see parentheses, we want to distribute. So this becomes -3 minus 3 times 3 is 9. And minus 15 minus 15n.
And it's very important to distribute the negative sign in front of the 5.
Perfect.
A lot of students were not doing that, and it changed the whole answer.
So let's see our like terms here. I know those two are like terms, and I know my n's are like terms. So if I combine this, -3 and -15, minus 15 is minus 18, minus 9 and minus 15, what is that? 24
n.
Doesn't matter what order, right? If I put the enter, it doesn't matter. So Miss Ewing, go ahead and you want to try number 5 and 6 there for you.
Okay, so for number 5, I'm going to combine my like terms.
Just giving you some space.
Thank you. All right, I see I have 1m squared, or not 1m squared. There's 6m squared, but there's only one term that has that. Then I'm going to use my m's, making sure to keep the signs with them as well.
That's very important because they don't take the signs over, get a completely wrong answer.
So I'm going to do this one step at a time so that I make sure do everything correctly. 6m plus 6.
And you forgot the 13n.
Oh, see?
There you go.
Forgot. No, I think you're right.
Remember, that's a totally different variable, so.
Right, so I can't combine that with anything.
Yeah. So we'll just be, what, 6m squared.
Okay, so my answer is going to be 6m squared plus 6m minus 13n plus 6 is going to be my answer.
So this was a four-point question. Each one of those answers was a point. So like if it was Miss Ewan, she would have just got 3 out of 4 for that. So you got to be extra careful with those variables.
Right, and so for number 6, again, I'm going to combine like terms. The first one is going to be 8t to the 4th power. Then I see I have 26t and minus 4t. So I'm going to combine those. My answer is going to be a positive 22t. Right? Then I see I have 17, 9. My answer is going to be negative 8. This entire thing is my answer.
So the goal is for us to just combine our like terms. We're going to move on with solving simple equations. Let me just clear out here. Bring these down. We have 4 of these questions. This is from like simple 1-step, 2-step. Both of us were able to get this correctly, so this shouldn't take us that long. Go for it, Miss Ewing.
Okay, so I'm going to start farthest away from my variable. Positive 3, the inverse is to subtract 3. This cancels out, bring down my 9u. 21 minus 3 is 18. Now the inverse, 9 times u, the inverse is going to be to divide by 9. My 9 cancels out, and u is equal to 2 as my answer. Okay, moving right along to number 8. Again, I'm going to start with my variable, so I'm going to subtract 3g from both sides. And again, if you do this a different way, that's fine. This is just how I'm choosing to do mine. 6g minus 3g. 3g plus 15 equals 8. I'm going to subtract my 15 so I can isolate my variable on the left. 15 cancels out. I'm left with 3g equal to negative 7. Again, the inverse is division. My 3's cancel out. Rewrite it again so it's more clear. G is going to be equal to negative 7 over 3, and I want to leave that as a fraction.
What if I put it as a decimal, Miss Ewan? Does it matter?
It doesn't matter, as long as that would be equivalent or equal to negative 7 over 3.
Okay, perfect. So let's move ahead, guys. We have number 9 and 10. So let's get that here.
All right, so again, I see I'm going to distribute first my 5. Next step, I have 5y plus 30 equal to 9y minus 10. I know that 5 times 6 is going to give me 30. I'm going to subtract 5y from both sides. My 5y cancels out. I'm left with 30 equal to 4y minus 10. Now I'm going to add 10 to both sides so that my 10 will cancel out. I can isolate my variable. I'm going to move this to the right so I have more space. That becomes 40 is equal to 4y. I'm going to cancel out my 4 by division. Okay, y is equal to 10, or 10 is equal to y is going to be my answer.
Seems easy. Last one, solving.
Okay, so this one, only one step. I'm going to do the opposite. The inverse, divide by 4 on both sides. The 4 cancels out. N is now equal to 5, and that is my answer.
All right, moving on to our next part, which is solving inequalities. Some of us was having some little issue with this. I'm going to take 11 and 12. Miss Ewan, do you want to do one of these two? Take 14?
Right, I'll take 14.
So, whenever we're doing this, just like you did before, we're going to solve for the variable. So let's take this part over here. Minus 5 is greater than 7. So, I want to get r by itself, add 5 on both sides. These are cancel, negative r is greater than, this is 7, 3, 10, 12. But notice that it's negative r.
Miss Samaru, I think that's a 5.
Yeah,
Oh,
that's
no,
a 5.
you're right.
7, 3, okay, thought it was late afternoon, sleep, nap time. So because it's negative, I need to get rid of that. So I need to divide by a negative 1 because we have that invisible one right there. And remember, when you divide by a negative, what happens? We flip the sign. So very important. So this, and I'm going to just I'm all over the place, but this becomes r. So this side's change to the opposite way. So it's less than negative 12. Now graphing this, I'm at negative 12. It's an open circle because it's less than, and anything less than goes to your left. So that would have given you 4 points. Let's try this on number 12. So just break some space here. Number 12, I am going to 9 is greater than minus 4. So add 4 on both sides, just like we would in a regular equation. This is cancel. 9, 13. And remember when I say graphing this, we read it from the variable. So I'm going to start at n. N is less than or equal to 13. Graphing this, I'm going to find 13. It's a shaded circle because it's less than or equal to, and anything less than goes to the left. See, it's not as difficult as you think. Now, what's going on here? Let's rewrite this so you can see it properly. Just like you would in one of those simple equations, we're going to distribute. This becomes 88 is less than 8v plus, what's 3 times 8, Miss Ewing?
It's 18. No, 24.
24. So, how would I do this? Get rid of 24 on both sides. 24s are cancel. What does this give me? 64 is less than or equal to 8v. Now I need, where should I go? Let's go over here. Now I need v by itself. So I have 64 as I divide by 8 on both sides. My 8 cancel, I'm left with v. And 8, I know 8 eighths is 64. So remember, graphing this, I need to read from my variable first. I need to read from here. So this is read as v is greater than or equal to 8. Because it's greater than or equal to, I'll have a shaded circle. Anything greater than will go to the right. So let's just make some space for Miss Ewing to come. And we're going to be doing number 14.
All right, thank you, Miss Samaru, for saving the really long one for me.
I tried.
All right, so there's a lot going on here. I'm going to rewrite it again so it's more clear. So I have negative 5 times parentheses 2x minus 4 is greater than negative 2 times parentheses of x plus 6. I'm going to distribute my negative 5, making sure I keep the negative when I distribute. That's going to give me negative 10x plus 20. Negative times a negative is a positive. Greater than negative 2 minus 12. Okay, for my next step, I want to isolate my variable. I'm going to bring everything up.
I know we're limited on space, guys. Sorry.
Sorry. I'm going to rewrite it again just so it's clear. Okay, so I'm going to start with my 20, positive 20, subtract 20 from both sides, like you would if there was an equal sign. My 20 cancels out. I have negative 10x is greater than negative 2x minus 32.
Does it matter which one I move first? Like, what if I wanted to do plus 2x? Does it matter?
No, it doesn't matter, either one, but I chose to work away from the variable first.
Can't see the black.
Okay, so now I'm gonna make sure my variable's on the same side. I'm gonna add 2 to both sides. All right, this cancels out just like in a regular equation. I now have negative 8x is greater than negative 32. My inverse, I'm going to divide by negative 8. I'm going to remember to flip my sign. Whenever you have a negative sign in the denominator, you flip. So x is now less than 4, and that's a positive 4.
So let's just clear up some space so you guys can see how we graph it. We got up to here. Miss Ewing, it looks a little confused. You want to do that piece again?
Okay.
Just divide by where we negative 8.
So again, yes, we are dividing by negative 8. My negative 8 cancels out. If x is now less than a positive 4, I'm flipping my sign because I divided by a negative. Now graphing this, x is greater than 4. I'm going to have an open circle, and everything less than goes to the left.
All right, that was a long one, Miss Ewing.
Yes, it was.
Moving right along. Oh, factor.
All right, I think I can take this one.
Go for it.
All right. So as we learned before, I'm going to pull out my coefficients from the equation. Factor can mean different things, but this is the type of factoring that I'm looking for in this question. My a, x squared, is going to be 1, b, 13, and c, negative 30.
Remember, guys, just to add there, anything that has a square, that's a quadratic. We know we're going to get 2 answers.
Right.
Sorry, Miss Ewing.
No, thank you, Miss Amaru. For my next step, I know that on the top of my x, I'm going to need to multiply a times c, and the bottom I'm going to need b. So a times c is going to give me negative 30, b is 13. This one was very difficult. I needed to think many times about the factors of negative 30 that would add together to give me 13. But eventually I figured out that it was 15 and negative 2. So now I pull this out into my parentheses. I have x plus 15, and I have x minus 2.
I know a lot of you are stuck here with 10 and 3. But remember, it has to multiply to give me negative 30 and add to give me a positive 13. Do you want to take the next one? I'll do the absolute value one.
Sure.
Again, it's graphing inequality, guys.
Right, so for 16, I'm going to separate this again and rewrite it. I have negative 3x is less than or equal to 0. I know that I'm going to divide by a negative 3 so I can get my x by itself. The 3 cancels out, and remember I need to flip my sign because I've divided by a negative. So now x is going to be greater than or equal to 0. I'm going to graph that before I forget. X is going to be, my point is going to be a closed circle at 0, and I know that it's greater than, so it's going to be everything to the right. For the second half, I'm going to rewrite it again. I know that x minus 9 is less than negative 10. I'm going to isolate my variable, add 9 to both sides. The 9 cancels out. I'm left with x is less than negative 1. I'm going to go back and graph that again on my number line with an open circle.
Why is it an open circle?
It's an open circle because it doesn't have it only has the less than sign.
Got it. If it was the line at the bottom, the equal, then yes. I put a close. Got it.
Right, so if it was less than and equal to, it would be a closed circle, but it's not, so I know it's going to be an open circle.
Got it.
All right, and so x is less than negative 1. Less than always goes to my left.
All right. This is where we had some problems with our absolute values. So please pay extra attention while we go through this step by step. So really quick review, we know that absolute value are always in the form, my absolute value side, ax plus b is equal to c. And my c is always positive. So I have to ask myself, is everything in my absolute value side, is there anything that's just around? Excuse me. So since it's not, what I'm going to do, I'm going to split these up. Remember, absolute value is a V shape. We always have 2 answers. So this is everything in my absolute value side is equal to my C, in this case 49, or everything in my absolute value is equal to negative 49. Remember, it can equal negative 49 because if I take the absolute value of a negative number, it becomes a positive. And then I just go ahead and solve this like a simple one-step equation. Divide by negative 7 on both sides. X is equal to negative 7. That's one answer. Divide by negative 7 on both sides. X is equal to positive 7. So that's my two answers. Now look at number 18. See, there's a 7 right here. That's just lingering outside. So I need to get rid of that. Remember, I can't distribute because absolute value is different from a parentheses. This is multiplying, so I need to do the inverse operation. So divide by 7 on both sides. My 7s are canceled. Then I have an absolute value of k plus 8 is, close my absolute, is equal to 10. Now that everything is in the absolute value side, I can go ahead, just like what I did in number 17, and split this up. K plus 8 equals 10, or k plus 8 equals negative 10.
So, Miss Samaru, the trick is I split it after everything is inside the absolute value?
Yes, everything has to be in the absolute value before I split these up. And then once you have this, I'm pretty sure you guys can get this out. You solve this, minus 8 on both sides, this is one answer, bam, k is equal to 2. Or, minus 8 on both sides, k is equal to negative 18. And those are my two answers. So the key is, just like Miss Ewan said, we have to make sure everything is in my absolute value sign. So moving ahead, number 19 looks pretty confusing because I have a 4 that's outside. I have a positive 6. So we always get rid of any plus or addition first. So I'm going to minus 6 on both sides. The minus 6 are canceled. 4 is great. Absolute value of 4p minus 1 is equal to 4. So, let me just get some space here. Now that I need to get rid, remember now I got rid of the 6, I need to get rid of the 4. Just like we did in number 18. Divide 4 on both sides. This is canceled. I'm just going to come up here. Absolute value of negative 4p minus 1. And 4 divided by 4 we know is 1. Now everything is in absolute value. This is where I split everything up. So everything in my absolute value, is equal to C, or everything in my absolute value is equal to negative 1. If I was to go ahead and solve this, I'm pretty sure all of you can solve this right now. If I was to give you 2 minutes, you'll be able to solve it. So, add 1 on both sides. This is canceled. Minus 4p is equal to 2. Divide by negative 4. My 4's are canceled. P is equal to 2 over 4, negative 2, or negative 1/2. Either one I took can give you full credit, guys. What about this? Same exact thing. Add 1 on both sides. Negative 4p is equal to 0. Divide by negative 4. P is equal to 0. Yep, this works out to be 0. So, number 20, last one here, and then I believe we have 4 more questions to go, and that's it. So number 20, if we were to go ahead and start with number 20, again, the same thing. We have a lingering 3 and I have a lingering 2. So let's get rid of the 2 first. Minus 2, the opposite is adding 2. 2 is canceled. Negative 3, absolute value of 1 minus x is equal to negative 12. So far, so good? All right, let's get rid of this 3 now. Remember, this is multiplying. So the inverse of multiplying is dividing both sides by negative 3. This is cancel. Absolute value of 1 minus x is equal to a positive. Negative divided by negative is a positive. Now that everything is in the absolute value is where I go and switch. So this becomes 1 minus x is equal to 4, or 1 minus x is equal to negative 4. So let's see how we're going to get this done here. Do we have any more space, or should I go to the side here? So if I was to break this up, 1 minus x is equal to 4. I would, what do you want to do, Miss Ewing? Should we move the x or the 1?
I think we should move the 1 first.
1 minus 1 on both sides. The 1s are canceled. Minus x is equal to 3. But be careful, this is minus x, so I need to divide by a negative. Remember that invisible 1 there? X is equal to negative 3. Perfect. And let's bring this other one. We have, what was it? 1 minus, that's not 7.
1 minus x equals negative 4.
Good. So now, Miss Ewan, let's say we want to move the x, because it really doesn't matter what we want to do. So add x on both sides. This is canceled. 1 is equal to minus 4 plus x. Now, I want to get x by itself. I add 4 on both sides. This is canceled. 4 plus 1 is 5 is equal to x. So we have two answers. X equals negative 3 or x equals 5. Either way you work it works out to be fine. Oh, I know it's a long video, guys, but it's just review. Now, solving for the variable. Some of us were having, I think this is, we have 5 more questions to go. So I want to solve for the variable in parentheses. I'm solving for h. So the first thing I want to do is get rid of my denominator. My denominator is 2, so I times 2 on both sides. This becomes 2a is equal to bh. I don't write the 1 because if I multiply anything by 1, I know it's myself. So divide by b because I know this is multiplication. That's canceled, and I'm left with 2a divided by b is equal to h. Remember this, I didn't need any numerical answer. We're just solving for the variable. I'll do 22, Miss Ewing, and you take 23, 24.
Okay, sounds good.
So, I want to solve for y. So let's make y positive first thing. Add 5y on both sides. This is cancel. 4x is equal to 9 plus 5y.
Wait, Miss Semaru, why can't I combine 4x minus 5y?
I'm sorry, why can't you combine what?
4x minus 5y?
Because they're not like terms. They're two different variables, so we can't combine that. Good question. So, minus 9 on both sides. My 9s are canceled. 4x minus 9 again. These are not like terms, so I can't combine these. Is equal to 5y. Again, I want y by itself, so I divide by 5. This is canceled. 4 over 5x minus 9 over 5 is equal to y.
Wait, so Miss Semaru, how did you get two different fractions in your answer?
Well, since this denominator, this line, look at the line, is split between both terms. So I just split it up to make it look pretty. That's all I did, was to make it look pretty. You guys know I like to see stuff neat and it looks pretty. So we have 2 more questions to go. I'm going to clear that off. And Miss Ewan's going to take 23, 24, and 25.
Okay, so for number 23, I see that I have a k in my denominator. I'm going to get rid of that first.
What are we solving for again? I
Oh,
didn't
right,
see.
Miss Semaru, we're going to solve for b.
Perfect. Sorry, I wasn't paying attention.
No, it's okay. So I know that k cancels out. I'm left with a plus b is equal to 1k.
Can I just write k by itself? Does it matter?
Yes, you can. 1k or just k, they mean the same thing.
Okay.
So I know I'm solving for b. I'm going to subtract a from both sides. My a cancels out. I'm left with b equal to k minus a, or b equal to 1k minus a. They're both the same thing. And that's going to be my final answer.
That one was fast.
Yes. Number 24 was very difficult. I saw a lot of students doing a lot of different things, but I want to try it the easiest way that I know how to do it. So I'm solving for x. I'm going to work with the variable farthest away from my x, which is going to be plus b. I'm going to subtract b from both sides. I'm not going to combine y and b because they're different variables, so they're not like terms. So I have y minus b equals mx. I'm solving for x. I'm going to divide by m. My m cancels out. What I do to one side, I do to the other. So I have y minus b over m is going to be equal to x, and that's going to be my final answer.
What about Miss Ewing? If I put this, would that be the same thing?
Right, Miss Emmer, that is the same thing because
Oh,
it's,
okay.
right.
So either one works.
Either one
Check.
does Yes, either one does work. But what wouldn't work is if I had y over m minus just b by itself equal to x.
Oh, so we have to remember to divide the b in both terms.
Yes.
Oh, I got it. Guys, be careful with that error, okay? If you do the b, if you do this b right, this m right here, you have to do it to the y term and the b term, okay? Some of you make that mistake on the test. Remember, every point counts for the regions. And then our last question to wrap our test. What's my a, what's my b, and what's my c? Here we go.
All right, last one. So I have x squared. I know there's an invisible 1 in front of it. My b is going to be negative 16. Always keep my negative with it. C is going to be 64. I'm going to make my x. I know that the top is a times c. The bottom is b. A times c gives me a positive 64. B is negative 16. So now I need to think of numbers that will multiply together to get me 64, but will add together to get me negative 16.
Wait, the top is multiplying and the bottom is adding?
Yes. Okay, so, and I think my answer, I think that negative 8 and negative 8 can multiply together to give me a positive 64 and add together to give me a negative 16.
But let's check it really quick, guys. 8 times negative 8 is a positive 64. Check. Negative 8 plus a negative 8, and I like to keep my negative, is a negative 16. Check.
And we're good. But I'm not quite done yet. I know that my answer is going to be in the form of 2 parentheses. I have x minus 8 and x minus 8. I'm making sure that I keep my negatives in my answer.
Remember, guys, this is the same what you learned in Algebra 1 with Miss Shiny. Okay? So, yes, that's my final answer. So, there was your first test, 100 points. Let's look at the extra credit. I actually put this in there just to tease you a little. So the first part of it, say, look at this graph. What is f of 1? All that means, we just talked about this. That's not for you to see. We just talked about this. What's the value when f is 1? So this is, remember, this 1, that's my input. And that's my x value. So when on this graph, this is my x equals 1. I want to know what is this value right here. What's my output? So at this point, it's 3. What's my y-intercept? My y-intercept is where the graph intersects the y-axis. Remember, this is my y-axis. That's my x. So the graph intersect right here. What's that pointer, Miss Ewing?
That looks like it's a positive 2.
Perfect. Now, f of x is equal to 3. We talked about the difference between a and c. I want to know what value do I plug into x so I get a 3 as the answer. And those of you that did the first one, you will know when x is 1, that's when it's 3. So these two are actually the same exact thing. It's just for you to know what they mean. And the x-intercept, this is where the graph, and if you want to make a note of it, that's fine. The graph intercept, here you go, the x-axis, or where it crosses the x-axis. So I know it's somewhere here. I took a various answer. That's approximately negative 0.75. Some of you were a little off. That's fine. But if you had something along that line, I took it. Now, the last part of this extra credit. So, same exact thing. What's my A, what's my B, and what's my C? My A is 9. My B is negative 6 and my C is 1. X method. What goes on top? A times C. A times C is 9. And my B term goes in the bottom, which is negative 6. So, two numbers, when I multiply it, I get a positive 9. But when I add it, I get a negative 6. Miss Ewan, you want to help me out?
Sure, I do.
What is, tell me my two numbers.
Okay, so my two numbers are going to be negative 3 and negative 3.
Are you positive? Let's check this out, because negative 3 times a negative 3 is a
Positive 9.
Oh, check.
We're good.
Negative 3 plus a negative 3 is a?
Negative 6.
Oh, so we're good.
And we're good.
So, the only thing with this, we cannot write x minus 3 and x minus 3. This is a big no, it's in red. This is a special quadratic because my a, if you look here, is greater than 1. This is where I replace my b term. So I write my a, which is 9x squared, and I'm going to replace my b term, which is minus 6x. So, and because it's my b term, I'm going to add an x to it plus 1. And remember what we said, take the first two and see what they have in common. So this have a 3x in common. If I was to do this, this becomes 3x that's left over minus 1. If I was to distribute this like this back over, I have to get what I started with. Let's think about this. What do they have in common? They have nothing in common. But remember we said when they have nothing in common, it is a negative 1. So 3x minus 1. Remember I told you the little cheat? These two will always be 100% of the time will always be the same. Just because I want to make it look pretty, I write these back in the parentheses, and then I give the other one its own parentheses. So this will be your final answer. So these, because they're the same, I give them one parentheses in first, and then I take my 3x and my minus 1, and I give them their own parentheses, and then I become this. If you want to check your answer, the easiest way for you to check your answer is when you distribute this, it should give you back what you started with.
All right, I think I got it, Miss Emery.
All right, guys, this is our first review for Unit 1. Remember, come see us on Mondays if you have questions.